afternoon. I'm Spot On Weather meteorologist Matthew Euler, and today I'm going to take a look at La Nina and winter in general. It's an interesting topic and one that's very appropriate now that we're entering into a La Nina type of winter here in 2020. So first I'm going to start this presentation by asking the question, what is La Nina? What is it specifically? It is a phenomenon in which cooler than average sea surface temperatures are observed in the Nino 3.4 region, and that Nino 3.4 region in the equatorial eastern Pacific extends from 5 degrees north to 5 degrees south latitude and 120 degrees to 170 degrees west longitude. The diagram there, the upper right-hand corner of this slide, shows the Nino 3.4 region and generally where it's located. So what NOAA does is they look at a running 3-month mean or average sea surface temperature anomaly for this specific 3.4 region. Events defined as 5 consecutive overlapping 3-month periods at or above plus 0.5 degrees Celsius anomaly. That would be an El Nino event if it's 0.5 degrees Celsius or warmer than normal. And then at or below 0.5 degrees, negative 0.5 degrees Celsius anomaly for La Nina events. And La Nina comes in different categories. For example, you can have a weak La Nina, which you'd have a 0.5 to 0.9 degrees Celsius sea surface temperature anomaly from normal. A moderate La Nina from 1 to 1.4 degrees Celsius in that Nino 3.4 region, that sea surface temperature anomaly. A strong La Nina is classified as a departure of 1.5 to 1.9 degrees Celsius. And then a very strong La Nina is 2 degrees Celsius or greater in that Nino 3.4 region. So NOAA, the Climate Prediction Center, looks specifically at this particular area of the globe and the water temperatures and determines whether those water temperatures are warmer than normal or colder than normal. If they're warmer than normal, we have an El Nino. If they're colder than normal at 0.5 degrees Celsius or cooler than that, below normal, greater than that, then you have a La Nina. All right, so let's go ahead and take a look at the past 7-day sea surface temperature anomalies in degrees Celsius. This image is courtesy of Tropical Tidbits. The blue shading on this particular image shows where the sea surface temperatures or those water temperatures are below normal, blue shading. The orangish colors, the orange warmer colors indicate where the sea surface temperatures are actually above normal. So we have a lot of warm water situated off the U.S. west coast at the present time, and you have very much below normal water in that Nino 3.4 region. If you go west off the coast of South America, right along between 5 degrees north and 5 degrees south, between that 120 and 170 degrees west longitude, you're going to see colder than normal waters. And that is indicative of a La Nina, which we currently are in right now. This is the latest Nino 3.4 region, sea surface temperature departure from normal in degrees Celsius. The latest value as of 16 October was at negative 1.154. So we are exceeding that. You notice the negative 0.5 threshold. We are easily exceeding that. We're actually over a degree Celsius cooler than normal for the water temperatures there in the Nino 3.4 region. And being a degree cooler, that gets back to our categories. We're looking at a moderate La Nina at this point. That would be a moderate La Nina classification. All right. Now, what kind of typical La Nina? What does La Nina do for the typical winter setup is what I'm getting at here. The graphic on the left shows the La Nina December to February time period, shows areas where across the globe that are either drier or cooler than normal, drier or warmer than normal, perhaps wetter or cooler than normal. That graphic there on the left shows that. And so for the United States, we have cooler than normal conditions into the Gulf of Alaska, into western Canada, all the way down to the northern plains, parts of the Pacific Northwest up towards Washington State and parts of Oregon. While the Gulf Coast states are drier and warmer than normal, there is a little pocket of above normal precipitation there in the Ohio River Valley during La Nina episodes typically between the months of December and February. The graphic on the right shows the general jet stream setup, that purple line, showing a blocking high pressure system situated around the North Pacific in the vicinity of the Aleutian Islands in Alaska. You get a big dip in the jet stream, directing colder than normal air from the Northwest Territories, from Western Canada down into the Northern Plains. And so you can see that blue shading on the graphic on the right indicating those colder than normal temperatures. And then up through the mid-Atlantic, you typically have milder than normal temperatures for the winter season, December to February. Now, I wanted to show this as part of the video today, the NOAA 2020-2021 Winter Outlook. And this, right when I saw this come out yesterday on October 15th, I said, wow, this is a complete re-imaging of a typical La Nina winter for the United States. Where you have your above normal temperatures across the southern U.S. from California over to Florida. That's your greatest probability of above normal temperatures. That probability does decrease as you go further north, closer to the Ohio River, as well as up towards the midwestern U.S. And you notice cooler than normal temperatures are forecast for the winter outlook for parts of the Pacific Northwest and the northern plains. The white area there on the left-hand graphic shows near average temperatures for the winter. The graphic on the right shows the NOAA precipitation outlook for the winter of 2020, December to February. And you'll see the green shading indicating above normal probability of precipitation, a higher probability of above normal. And then the brown shading, again, dry along the Gulf Coast states in a La Nina, typical La Nina setup. So the NOAA outlook really does mimic the actual La Nina winter setup here. The general conditions you would expect with a La Nina. So just wanted to show that and get that out to you. Now these are the La Nina and winter temperature and precipitation anomalies. I got 3 different rows I'm showing you in this graphic. This is, by the way, courtesy of NOAA Climate Prediction Center. The graphic on the left, the row of maps on the left, shows December, January, and February La Nina temperature anomalies in degrees Celsius and their frequency of occurrence. So the blue shading there on the far left, upper left, that composite, that shows below normal temperatures, whereas the more the tan shading indicates above normal temperatures. And then the frequency of occurrence is right next to that, showing, orange is, for example, orange represents 70 to 80% frequency of occurrence, with the actual cases in the years below these graphics, these particular maps. The row there in the center shows December, January, February La Nina precipitation anomalies in millimeters and the frequency of occurrence. Brown shading indicates below normal precipitation, green and blue shading above normal precipitation. And generally you have warmer and drier conditions along the southern U.S. from California to Florida, and even extending drier than normal up into the mid-Atlantic states. And you have warmer than normal conditions stretching from Texas to the mid-Atlantic. The far image on the right there, December, January, February La Nina snow anomalies in inches. Blue shading indicates above normal snowfall, brown shading below normal snowfall, and then the white is kind of just in between. The white shading indicates near normal snowfall. So this is a great source. You can get this on the Climate Prediction Center website. You can get a look at the different composites here with a La Nina winter for the months of December, January, and February. So again, NOAA is pretty much going off of what's occurred in the past for their outlook for this winter, with a La Nina, 85% probability of a La Nina occurring through the Northern Hemisphere winter. So really no surprises here in this outlook issued yesterday. All right, but here's one thing I wanted to bring up of really great interest. Not every La Nina winter is exactly alike. And there are some really interesting examples of the past in the Mid-Atlantic. There's been some pretty good snowstorms even during La Nina winters. And so you can't automatically just discount by looking at these composites and this outlook. You can't just automatically discount the information here and think, it's just going to be a La Nina, warmer and drier than normal winter across the Mid-Atlantic. There are some cases where some big wintertime storm events did occur during La Nina winters. This particular graphic is a really nice, handy one. This is showing temperature anomalies. temperature anomalies in degrees Fahrenheit. And the blue shading on these graphs, on these maps, indicates colder than normal temperatures. The red and the orange shading indicates above normal temperatures. So the first three at the top there, going across, the first row at the top, this is indicative of December through February temperature anomalies for all La Nina winters, for all of them. It's almost like a composite, putting together all the La Ninas of the past. Note the warmest temperatures, that orange shading extends from the Gulf of Mexico to the mid-Atlantic. The middle row shows December, January, and February for a negative North Atlantic oscillation. Now, I did briefly talk about the teleconnections, the NAO, in my last video on the Spot on Weather Winter Outlook. But if you take a look at this, this is real interesting. So even despite the fact it's a La Nina winter, the middle row shows the hue of blue shading for December and January especially being really below normal from the northern plains all the way to the southeast, all the way down to the mid-Atlantic into Florida, really. So the warmest temperatures in the La Nina winters with a negative North Atlantic oscillation for December, for example, was very much warm and very dry and above normal out in the western U.S., southwestern U.S. The bottom row shows December, January, and February La Nina conditions with a positive North Atlantic oscillation. So look at that. Look at how much warmer the eastern U.S. is in the bottom three images there, that maroon shading. December, January, February just looked like they were non-existent. So it's really interesting to note, again, that not every La Nina winter is exactly alike. And you can have another teleconnection that comes along, like this North Atlantic oscillation, those middle three images, the middle row, and produce below normal temperatures in a La Nina winter. Even though you would say, wait, it's supposed to be drier and warmer than normal. So again, something can easily offset the impact of La Nina. Now this is the ENSO, the El Nino Southern Oscillation changes. These occur on a cyclical basis. You'll see peaks and valleys, ups and downs. This is the 3-month region, the 3.4. We're looking at the Oceanic Nino Index. And you notice the graphs going up and down here, the little the peaks and then the troughs. And you'll notice that red numbers there indicate the year in which we had strong El Ninos. So if you see a 57, 58, 65, 66, 1972, 73, 1982, 83, 1987, 88, 1991, 92, 97, 98, and then 2015, 16 all had very strong El Nino years, okay? And you're looking, for example, in 2015-16, you were at the Nino 3.4 region was 2.5 degrees Celsius above normal in that area of the water temperature. In addition, if you look at the bottom in the blue shading, 1973, 74, 75, 76, 88, 89, 98, 99, 99, 2000, 07, 08, and then 2010, 2011. Those were stronger La Nina episodes. And then if it's black, if the years are in black, that indicates moderate. So either a moderate level, either El Nino or La Nina, depending on whether it's a peak or a trough. So it's really interesting to look. This is a climate variation that occurs on a cyclical basis. It goes ups and down. It has ups and downs like this. And typically ENSO, whole ENSO evolution occurs on a 3 to 7 year period, the ups and downs. Now this shows the ENSO intensity. Now that does make a big difference in what kind of weather we can expect this winter. If you look at the El Ninos and the classifications again, whether they're weak, whether they're moderate, strong, or very strong. And then on the right-hand part, we show the La Ninas, weak, moderate, or strong. So just some key years of some of the more weaker La Ninas there, as recent as 2017-18. And I will mention that year, in 2017-18, that winter, Virginia Beach, in particular Southeast Virginia, saw a very big storm, actually anomalous snow from Savannah, Georgia, all the way up the coast in that 2017-18 winter during a weak La Nina. So again, it can happen. Moderate La Ninas as recent as 2011-12, and then strong La Nina occurred as recent as 2010-2011. Now right now we're in the moderate category for the La Nina. We're currently standing at a moderate La Nina based on the water temperature departures there in the Nino 3.4 region. So here are my final thoughts on today's video. I just want to emphasize La Nina winters, yeah, they typically favor warmer and drier mid-Atlantic winters. Typically during La Nina you get those warm and dry mid-Atlantic winters. But not all La Nina winters are ever exactly alike. Just like a person, no two people are ever exactly identical. Everybody's got a different personality. The same thing happens in the atmosphere. Things do not line up perfectly to where everything is the same. Strength of the La Nina is an important factor to consider this winter. I mean, if you look at the classifications again of the categories of the strength of La Nina, that can make a big difference. A weak La Nina, for example, may not have as big of an impact as a strong La Nina. So it's just something to consider. Other teleconnections can favor colder and wetter winters, and that would offset the typical La Nina winter pattern. You know, if we get in a favorable phase of the Madden-Julian oscillation, the MJO, a colder phase, phases 8 through 2, you could typically see the MJO be the dominant player for the upcoming winter. The North Atlantic oscillation, already mentioned about that with these graphics here in the middle row there, those 3 December, January and February with negative North Atlantic oscillations. That does make a difference in the overall temperature departures from normal. And the bottom 3 show a positive North Atlantic oscillation. So yes, you can have these things happen, these teleconnections, which can offset the impacts, really can offset more of a destructive interference situation. The Arctic oscillation, very important as well as the Pacific North American pattern, and also something known as a quasi-biennial oscillation, whether that's east or west for a particular winter. Additionally, solar activity can contribute to blocking patterns into northern latitude oceans. This allows for a more sharply amplified polar front jet stream, a more amplified meridional long wave pattern in general. And then the strength of the polar vortex is another important consideration. With a blocking pattern in the high latitudes, again, what happens is that polar vortex may become weakened or get displaced off the pole, resulting in more Arctic air outbreaks in the mid latitudes. So you get more of an amplified wave pattern across the northern hemisphere in this case, where the coldest air is actually dislodged into the lower 48 instead of remaining up near the polar areas where it typically resides. So there's a lot involved here. Just wanted to do a quick video today on La Ninas. What exactly is La Nina? Again, it's a cooler than average sea surface temperature or water temperatures in this Nino 3.4 region. And the way it's classified is 5 consecutive overlapping 3-month periods at or below the 0.5 degrees Celsius for La Nina. And there's your categories once again: weak, moderate, strong, and very strong. And again, the blue shading in this particular graphic shows the below normal water temperatures in that particular 3.4 Nino 3.4 region. There is your actual running sea surface temperature departure from normal based against climatology, below 1 degree Celsius below 1 degree Celsius below normal, colder than normal right now in that particular area as of the 16th of October. Here again is our typical setup. The NOAA winter outlook we discussed, which resembles more of what you would typically see in a La Nina pattern, warm and dry for the southern U.S. in the mid-Atlantic, cool and moist in the northern plains and Pacific Northwest. So that's very typical. And again, the cyclical nature to El Nino and La Nina. These occur on a recurring basis on 3 to 7 years typically. And that is all I've got for today. I hope you enjoyed this presentation on La Nina winters. It's going to be interesting to see how things shape up this winter. We've already seen a negative AO, negative North Atlantic oscillation, already quite a bit of blocking going on here in the month of October, which has really amplified the pattern and has buckled the polar front jet stream into the Midwestern and Eastern U.S. So it's going to be really interesting to see what comes ahead. Stay with us at Spot On Weather for further updates on the weather to follow. We hope you have a great Friday, everybody. Enjoy your weekend. Take care and stay healthy.